Right. So work, power, energy. Now, shall we do the correction here? Power. This will be the only correction. You don't call it strength, power, work, power, energy. Right. So what's simply work, power, and energy? Can you tell? What is work? What is power? What is energy? What is the difference? Johan, huh? Yes. Tell. Kali, tell. What is work? What is power? What is energy? What is work? What is power? What is energy? Yeah. You had to put the effort to do a work. Right? You had to put the effort to do a work. Yeah, usually work is done on a certain distance with a certain force, with a certain effort, right? Yes. So now this is what work, power, energy will be looking like. Let's say the easy example is let's say someone is either Johan or Avishka is going to the gym. See, so you are going to the gym and you are trying to work out, right? So let's say someone is telling that Johan doesn't have any energy, that guy is just bluffing of everything, he doesn't have any energy. Now he wants to prove it that I have energy, right? So he goes to the gym and he's trying to pull a weight, right? So when he is pulling that weight, that's then only we can understand that he has energy, right? That is only then we can understand that he has energy. Otherwise, without doing any work, can we tell that somebody has any energy? Can't, right? So energy to show up, a work has to be happen. When the work is happening, energy appears, right? So the work is a way of expressing the energy, right? Otherwise we don't know the energy is there. So the energy, yes, energy කියලා කියන්නේ work කරන්න තියෙන ability. So but the energy cannot be seen, right? ඒක පේන්නේ. Energy appears when you are doing a work. So more or less work and energy are same and they have the same units, which is joules, right? Which is joules. So the other one is power. What is power? What is power? Yeah, energy divided by time or work divided by time as in equation. As in general, what is power? Bro, Johan, what is power? Don't tell me it's a beer. Huh? Once Ranil said it's a beer, right? He likes power. Some guy asked what do you like? Some beer brands, and he said power. I don't know those elections. So he is down. Forget that. What is power? So what is actually power? What is power? No idea. I don't care. Huh?
The energy you use to do certain work.
That is still work. Yes. Now it's something like this. Let's say then Johan is working out in the gym, right? And Ravishka is coming, and Ravishka is saying, "You have more power than Johan." Right? Let's say challenging Johan that I have more power than you, and he is going to prove it, right? So how does he gonna prove it? So you have to put a weight. Let's say we are giving him 60 kilogram of a weight of a deadlift. Not enough, 100 kilogram. 100 kilogram of a deadlift is given, right? So now Ravishka goes down and takes the barbell and lifts the 100 kilogram of a weight. Like God knows what happens. So let's say he's ඉලයට කියම යන්න පුළුවන් කොහමරි ඉස්සන් like he took like much more time and now the Johan comes. Now you like Ravishka lifted it to a certain height, let's say 1 meter or something, not half a meter. Now Johan is also lifting it up to half a meter and the same weight. So the work done by both are same, equal, and the energy wasted is also equal. But now the Johan comes like a gym papa and he lifts it nothing, right? No milliseconds taken. So now who has more power now? Who has more power now? Now Johan have more power because he did it in just like this, right? So the power is something like that. No, like doesn't matter the work, what is the work you are doing, or like what is the energy that you are consuming. The actual thing depends on how fast can you do it, right? Like better, like faster you can do it, better your machine is. Yes, yes, yes. So faster you can do it, better your machine is. That is what it says, right? So the machines have these powers, right? The machines have power. So the power, like the more powerful machines do the work faster than the others, right? That's the simple definition. So how do you take the power then? So how do you calculate it in a formula? You divide the energy by the time taken, or you divide the work by the time taken. So that is power, right? Right. So shall we come to this one? Right. So the first thing is work, right? So now when it comes to the work, this certain theory, now this certain thing is very important. When you are calculating the work done, you have to consider two things. One is the force and the displacement, right? So you are applying a force on an object and you are displacing it for a certain displacement, for a certain length, for certain meters. So when you are displacing it, you have to consider one thing that is very important. The force and the displacement should be in the same line. Or in the theory what they say is like the force and the displacement should be in the same direction, right? Should be in the same direction, right? Force and displacement should be in the same direction. Like if the force and displacement are in the same direction, the work done, nice, it's clean, I thought, right? So if the force and the displacement, now this is the force, this is the displacement. If the force and the displacement are in the same direction, right? Are in the same direction, the work done is known W equals Fd, because if the force increases, the work will be increasing. If the displacement increases, again the work will be increasing. More you travel it, the more work done. More the force given, more work done, right? And tell me this one. You are applying a force to carry or like pull a object like this one in a in an angle of, let's say, theta degrees, right? The angle given is theta degrees. The force applied is F, and you are displacing it to a d displacement, right? Yes. Yes. So, oh sorry. Right. Now this is how the force is applied. Right. So this is how the force is applied. Still applying in an angle. Right. Now tell me, now the force is applied in an angle and the displacements happened in the horizontal line. Right. Force is applied in an angle, the displacement happens in a horizontal line. Is the work done equal to Fd or less than Fd or more than Fd? Now the force is applied in an angle, displacement happens in the horizontal line. මේක හරි නෑ අඹයක් දාලා මෙහෙම ඇදගෙන යනවා. මෙහි ඉන්නේ නැහැ. මෙහි තමයි ඉන්නේ. පොළොව දිගේ තමයි ඔබ්ජෙක්ට් එක යන්නේ. හැබැයි අපි apply කරන්නේ force එක in an angle. Still the object will move on the floor in the horizontal direction. Now the same thing happens here. Now my question is, the work done there, is it equal to FD or less than FD or more than FD? Less than FD. Work done is more than FD or less than FD? Bro, use your brain, think. Don't say I don't know. More. Angle එක වැඩි වෙනවා කොහොමද වැඩි?
into cos theta into d එක ගන්න. එතකොට fd එකට වැඩි අතන theta value එකකින් වැඩි වෙන හින්දා ඒක වැඩි වෙනවා.
Is it good? Less. Come on, less. Only bro is saying more. No.
අතන වැඩි වෙනවා කියන එක විතර.
Penuja.
cos theta එකකින් දශම ගණන අඩු වෙනවා නැත්නම් වැඩි වෙනවා. මේක දෙපැත්තට
Usually the sin costan, bro, sin costan value doesn't go above 1. The maximum will be 1. Right, the maximum will be 1. They don't go above 1, right? So usually what we do is, when we are taking a component, we consider the, listen, when we are taking a component, we consider the given force as the resultant force, and we are taking a component of it, and it has two components, and the two components together give the resultant force, which is the force we are considering, right? So always the force we consider is the resultant force, and the component we are taking should be less than the resultant force, because two of the resultant forces makes the, sorry, two of the components makes the resultant force. So two of the components should be less than that force. That is one thing. And the actual work done here isn't done by F, is it? It's not done by F, right? The actual work done here is done by not F but F cos theta. The actual force which the work is done is actually the component of this, which is acting in the direction of displacement, right? So there is a component in this direction. Did you get it? There's a component in the direction, in this direction, direction of flow. There's a component in this direction, which is F cos theta, right? So the force, the actual force which the work is done is F cos theta, right? So the work done here is equal to F cos theta into D, which is, we are like reconstructing it as F D cos theta, because it's a multiplication. You can change the values, doesn't matter, give the same answer, right? 2 into 3 into 4 is same, 2 into 4 into 3, right? Because same values. Get it? Right. So if the force is applied in an angle, you have to take the component which is acting in the direction of displacement, or else you can do the other way, right? ඒක වැඩි questions වල එන්නේ නැහැ, ඇවිල්ලා නැහැ, but you can still consider the other way around as well. ඒ කියන්නේ අර brain එකේ මේ නැති කරගන්න එපා, මේ confuse කරගන්න එපා එකපාරට. Either you can take the component towards the, like, component in the direction of displacement, or you can take the component of displacement in the direction of force. Do you get it? No? Forget it. Huh? Oh, ඒ කියන්නේ අපි දැන් මේක වැඩි එන්නේ, හරිද? වැඩි එන්නේ. But you have to learn things නේ. You have to learn things. You can break into components, the force and displacement both are vectors. Displacement එකත් vector නේ. So vectors you can break into components at any time. So instead of breaking down the force, ඔයාට ඕන displacement එකේ component එකක් f direction එක පැත්තට ගන්න පුළුවන්. බැයිද? බැයිද පුළුවන්? පුළුවන්. එතකොට එන්නේ මොකද්ද? d මොන θද? rho d cos theta. d cos theta into f will give the same f d cos theta නේ. ඒකත් පොඩ්ඩක් consider කරන්න. In some cases it will be much more easier if you can think the both the ways. Do you get it? ඕනනම් direction එකේ component එකක් ගන්නත් පුළුවන් instead of taking the component of the force, because both the force and direction, like both the force and displacement are vectors. Vectors have components, right? Now ඒක ටිකක් hard වගේ නම් leave it, doesn't matter. හරි අතල්ලා දාන්න. හරි. Come to this one. In actions such as pushing a box or drawing a water from a well, a force is applied to an object to move it a certain distance. For this, effort must be exerted. This is called work, right? Simply put the multiplication of applied force. Simply put the multiplication of applied force and the displacement in the direction of the force is in the direction of force, right? When we make it important, in the direction of force. So the multiplication of applied force and the displacement in the direction of force is called work. Get it? Right. So here, if the force is angled, the displacement, it must be resolved in the same direction. Force එක angle එකක තිබ්බොතින් same direction එකට ගන්න ඕන. Right? Work is energy, right? Therefore the unit is joule, right? So work, energy both have the same joules. They have the same girlfriend, like joule. Let's say something like that. They both have joules, right? So we discussed this one, right? So if it is like, now the displacement is given in s, so work done is fs. You can take the fd, fine. And here it's fs cos theta because the force is in an angle, right? Now come to the energy. Give me a second. Right, guys. So energy is the ability to do work, as Spencer said, right? Ability to do work. There are different types of energy such as thermal energy, potential energy, light energy, electrical energy, and nuclear energy. Kinetic energy and potential energy are commonly referred as the now these are like different type of energies. But kinetic energy and potential energy are commonly referred as mechanical energy, because in the machineries and the mechanical stuff, the energy which is transferring is mostly the potential energy and kinetic energy. So these two energy types are known as mechanical energy, and these are very important, you know. These two energy types are very important, right? So come to the kinetic energy. Kinetic energy is the energy stored when an object is in motion, which comes to two forms, right? Kinetic energy කියලා කියන්නේ when an object is moving, there's a energy stored in it, right? A energy කියලා අපි කියනවා kinetic energy, and it has two types. One is translational kinetic energy, which is the kinetic energy moving in a straight line, and the other one is rotational kinetic energy, which is the kinetic energy when an object or something is, a mass is rotating in a circular motion, and those are two different energy types. And most of the time, to increase the energy, they are using the rotational and transitional kinetic energies together. I'll tell you the examples, right? So now come to this one. So now here the transitional kinetic energy is equal to half mv square, Now the important here is, now it's equal to half mv square, right? There's a v square there. What does it mean? It increases with the velocity, rather it increases with the mass. It increases greater with the velocity, rather it is increasing with the mass. Let's say like I'm gonna like take a mass of 1 kilogram, right? Now if I take a first I'm going to take all the values as 1, right? The mass is 1, the velocity is also 1. So how much will be the energy? Half, right? Mass is 1, let's say 1 kilogram, and the velocity is also 1, so 1 square, right? Now what is the final answer? E. 1 square is 1, 1 into 1 is 1, divided by 2 it's half, right? And I'm going to increase the mass by 2, right? I'm going to increase the mass by 2. Now tell me, half, now this 1 is 2, still the velocity is 1 square, so the energy will be 1. Get it? Now I'm going to do this. I'm going to keep the mass constant. I'm going to increase the velocity. So now half, the mass is 1 and the velocity is also 1. The final will be half, right? I'm going to increase the velocity. So half, mass is 1, velocity is 2 and its square. So the energy will be 2. Now how much has it increased? When you increase the mass, the kinetic energy increase only twice, only twice. But when you increase the velocity, it increased by 4 times. When you twice it, it increased by 4 times. If you thrice it, it will increase by how many times? 9 times, because it gets squared. 3 square is 9, right? So greater the velocity, it multiplies or it gets square and gives a greater value in kinetic energy. So it depends more on the velocity than the mass. Do you get it? Again, the object VC කරනකොට, let's say you are throwing it in a certain speed, and you're like second time you are throwing it twice the speed than the last time. What happens to the energy? It becomes 4 times more powerful. Speed එක double කරොතින් 4 times powerful වෙලා ඉන්නේ. ඒකට කෙලින්ම කට ඇතුලට දාන්න පුළුවන් ලෙල්ල පිටින්. හරි. velocity එක double කරොතින් හයියෙන් යනවා. Right. So that is transitional kinetic energy. And the next one is rotational kinetic energy. Now there is a rotational kinetic energy as well. There is a kinetic energy when something is rotating, right? So most of the time these two of the energies are used together, right? Let's say Johan Nair is traveling in a bus. He's always traveling in a bus now. Okay. In the Leyland he is traveling alone. Side deck and then a girl comes and mocks him. It's a girl comes and me ayya kohide yanne ne ayya kohide inne likewise me podda karadara karna. This could happen in this era, could happen at the hand has happened come on. Let's say it happened, right? Now what is the next movement of your hand? Going to slap. Right? So he is using the usual technique. So I'm going to like teach you something new and it's gonna profit you. Right? So let's say he is moving the hand in a straight line. This. it will be only the transitional kinetic energy, isn't it? Transitional kinetic energy will be there. Yes. Rather than hitting it like this, if we add the rotational, we'll give some extra energy. Happens, right? You try it, give some more energy, right? Rather than hitting straight, if you give some rotation, it will be more. Now for real, you try it, it gives more, bit of a more energy. Discolor happens. Yes, only on the face, huh? And the other one is sometimes you are like they are using a lens work dala karagola that is also rotational and transitional hydrostatic energy, right? So in other cases as well, like in the martial arts, when the people are fighting, how do you do a punch? You don't hit like this. You have to do a proper punch. It goes like it rotates. The hand rotates. It goes in a straight line, and all of a sudden it rotates. So like the transitional energy and the rotational kinetic energy both together gives more energy. That's a different case. That's a technique. But if you want more energy, but අර ට්‍රාන්සිෂනල් එක විතරක් යනවට වඩා දෙක එකට ගියොත් ඇයි කෙලින්නේ යන්නේ කැරකින්නේ එතකොට වෙන්නේ අර මේ කම්පෝනන්ට් එකෙන් තමයි නෑ කම්පෝනන්ට් යන්නේ නෑ ඒතර ෆෝස් එක හිම යනවා ඔව් එහෙම නෑ එහෙම ගහන්නේ ඇත්තටම මේ අර දැන් මේ බොඩි එකේ ඇනටොමි එක තියෙන විදිය තියෙනවනේ බොඩි එකේ ඇනටොමි එක සමහරක් තැන් වලින් සේෆ් වෙලා තියෙන්නේ සේෆ් ගාඩ් වෙලා තියෙන්නේ අපි එක එක ඇන්ගල් වලින් ගන්න මේ සේෆ් ගාඩ් එක කඩන්න දැන් අපි මේක මෙතන ස්ට්‍රේට් මෙහෙම ස්ට්‍රේට් ගහනවට වඩා මේක ඉන්වර්ටඩ් ගහුවොත් මේ මේවැ මුකුත් නැහැනේ ඒතකොට මේ හරිය වදිනකොට මොකද වෙන්නේ මේ අතල කඩාගෙන යනවා ඉන්වර්ටඩ් මෙහෙම ගහුවොත් මේ හරියට එහෙම කටින් එනවා ලංග්ස් එහෙම හරියට ගහුවොත් right even bullets listen right now even bullets now some bullets are there like they rotate when you shoot like the snipers some of the snipers have these bullets when it goes it rotates in some cases like it only goes in a straight line I don't think එතකොට එහෙම නැත්තම් ගොඩක් වෙලාවට බුලට් එක ගිහිලා වදිනවා it stops there if it rotates what happens it will make a hole it will definitely make a hole because the energy is more so the transitional energy we already know and the rotational energy now the people who did circular motion already knows others have to wait to know the proper meanings of these functions right I and omega so this I is more like mass but different from mass because the mass doesn't consider direction a displacement the mass doesn't consider displacement but when it comes to the I which is moment of inertia it considers the displacement as well it needs a displacement because when it comes to the linear motion the mass affects but when it comes to the circular motion not only the mass but the distance affects as well isn't it now if I rotate something charger ine I'll take this one current podinga so if I rotate this one with a shorter length it will rotate easy because it's a shorter length but if I increase the length what happens you can't even see it you need more effort to rotate it you call it the distribution of mass right so more the length distribution of mass is more the distribution of mass is moment of inertia so more the length more inertia right More the length, more inertia. And so when we use mass in the transitional kinetic energy, we use instead in the rotational kinetic energy what? Distribution of mass, right? Transitional kinetic energy की mass use करना, rotational kinetic energy की distribution of mass की use करना, because it considers in the rotational motion. The distribution of mass simply for now for you people, simply the distribution of mass is I, right? So it's a type of mass, more like mass but not equal to the mass, right? And omega is what? Omega is actually the what? Angular velocity, which is more like the linear velocity. The linear velocity moves in a straight line, but the angular velocity moves in a angle, in a circle. Angular velocity is like the angle divided by time.
How much of the time you
Yes.
used to
Travel the angle. So it's a velocity, but taken in angles, so it's angular velocity. Get it? So take it simple for now, right? So the equation is more like same, half I omega square. So usually the I is supposed to be given, right? So you will understand this part when you come to the circular motion, which is the next lesson. When you come to the circular motion, you will understand better about what the I is, right? And the omega is, I omega. Now this is named as omega. Make it deep in deep I කියන්නේ මොකක්ද කියන එක, the real state. You're learning it under the circular motion, right? Right. So do the first two questions quickly, and rest will be homework. Do it fast. First two. First two will be simple. Oh. Standard units in the Both the answers? So what is the first? 20 joules. Second one? 85 root 3. Confirm. Same. Raishi got the answers? Same. When is it? Johan? Yes, sir. Both answers? The back row. If you need support, guys. So this has to be happen. Like this should be doing by yourself, because you'll have to have some copy sessions for the 2026 and 2027. Do it. It's a good thing. One thing is like one of the best ways of studying is teaching someone. So teach someone who's in need, like the 2026 people and 2027 people. It's a good thing. We'll have the relationship as well. No, I mean the relationship means like a healthy one. It's a good thing, and you know, the knowledge has to share, right? Knowledge has to continue for the generation to generation. So you have to give your knowledge what you earned for the people, and you have to tell the real story of it. You know, they don't know it because they only consider it to a certain level. They may have like sort of different thoughts about how the technology exams will be, how the technology careers will be. They may have like different hopes, right? And the different ideas. So far you know more than them, and you know how the exams will be, how you know how the questions will be. So you have the better knowledge, and you know how you in a how much of a level that they should be getting ready for the exams, coming exams, right? How much they should study, you already know, because you've been there and you've been through it, right? So you already know how much they should study, how much of a concern that they should put. You know it, they don't know it, and they need to know it. Though I tell it, they don't take it serious. So you have to tell it, right? And tell the truth. And the other thing is, right? So even after the A levels, right? Even after the A levels, after you get the results, we have to consider so many things. We'll choose different paths, right? Depending on your requirements, we will choose different paths, and like keep the context even after the exams, even after the A levels. Keep the context, because sometimes some people selects better pathways than what they already have. That has happened, right? You know, there were some people who applied for, you know, the scholarships, who had ranks. I'm not telling that the Sri Lankan universities are bad, right? That's not my opinion. What I'm telling you is, some have dreams away from here, right? So they have some plans, and the maybe sometimes when you have a better rank and you apply for a scholarship somewhere, you get better opportunities than anyone else. You know, this one guy, he had this opportunity that he had a full scholar in China. Full scholar in China, that means food, accommodation, tuition, all are free. So they were given a boarding, which is a somewhat luxury one, with a common lobby for TV and everything, kitchen, and even the girls are living next to them. God knows what happens, but you know. So anyways, like they got the food for free, the you know, the accommodation for free, and the tuition for free. They only have to go there, and if they want, they can't do part times. That's one thing. The people who are getting a full scholar can't do part times. If they found they do any part times, everything will be finished. So if they had the chance to do the part times, they can earn as well, you know. So that's a different pathway, and in my opinion, I don't know what the others think. In my opinion, I hope that's a better way of, you know, improving or growing up your future, right? Because it's your future, so you have to do something best for yourself. That you have to take the advice, huh?
In
If I tell something like that, that will be debate. That is debatable, but I'm telling my opinion from what I have experienced so far. Occasion mean now I don't tell that. So the government universities here, I'm not telling they are bad in any sense. It's a different case. Oh, I don't know. I don't know. Right. Yes, but I can tell it directly because we have issues here. The recordings are there. I don't care. I'm gonna put it anyways. Pulwang, but why? What for? Right. So the question far away. Listen. So question number 3. Now label the question numbers. Listen. Question number 3, 4, 5, 6, 7, 8, 9. All homework. Do it all at home till the 9th question. Yeah. Right. Do it at home and bring with the how you got the answers. No. Right. Now come to this one. The potential energy. Right. Come to this one. The potential energy. This is also important. This is also important. Potential energy. Now, what is potential energy in the sense? What does it mean? Energy stored. Yeah, can take as that. Mostly the potential energy is stored energy when you are doing a work against a field or against a force that is acting in the opposite direction, right? There are two instances. One is when you are applying the force, like the force and the direction, like the force and the displacement are opposite to each other. Like one case is like the friction. The object is moving forward, but the friction force, which is a force, is acting opposite to the displacement. So now the two of the force and the displacement are acting oppositely. So is there a work done by friction at that time? Your opinion. The friction is acting oppositely and the displacement is opposite to the friction. Is there a work done by the friction at that time? Yeah. There is a work done by the friction, right? That work done by the friction is wasting energy. Yes, that's negative because it's wasting. It's wasting. Like most of the time it will be heat or something. It will be wasted, right? And you can take it as the work done by the friction as well, or work, it is actually called as work done against the friction. Work done against the friction. If you think about it, it's a bit of different. Work done against the friction is equal to the friction into displacement. So it's more like the work done by the friction, but the actual thing is it is the work done against the friction, not work done by the friction, right? So but we can take it as work done by the friction. What we do is same thing happens in the gravity. But when it happens in the gravity, what happens to the energy? It will store. That's the difference. Now this guy has a good brain. He doesn't use it properly, right? So let's say now this is a mass, right? So the weight is acting downwards, right? And I am going to lift it upwards. So I am acting against the gravity, right? I am acting against the gravity. And the work done here is getting stored in the bottle. How do you say it? If I leave the applied force, the stored energy will start to work back, isn't it? It will start to move back. So that is the energy that is stored, right? So the force is downwards, which is the weight, and the work done is upwards, So the work done against the gravity got stored in the bottle, right? That is the other instance that I said, like in some cases the energy is wasted, and in other cases energy is stored. So the gravitational potential energy is a chance where the energy is stored. The other one is elastic potential energy, which is again stores. Like let's say rubber patiyak wage එක. You draw it මෙහෙම අදිනවා හයියෙන්. ඇදලා now when you are drawing it, the force applied is against the elasticity, right? Because the elasticity tries to take it back. So there is a force against the action you are doing. But against that force, you are drawing it back. So the work done against the elasticity is stored in the object. So if you leave it, what happens? The elasticity does the work back, or the energy stored in the object will start doing the work back. Get it? So that happens. So that is also one of the potential energies. So when we discuss under the potential energy in this theory, we only discuss two, which is one is the gravitational potential energy, other one is elastic potential energy. Those are the two things. But there are more. As it comes to the batteries, what happens in the batteries? There's a static potential energy, or a static field is there. There's a plus terminal and a minus terminal in a battery, and the plus terminal repels the plus charges, isn't it? The plus terminal repels the charges. Plus charges, it's repelling. So what happens when you're charging a battery? You are storing the plus charges against the positive field in the plus terminal, don't you? Like there's a positive field in the plus terminal, and against that field you are storing the positive charges to the battery. You are doing something against, right? You are working against the field. You are working against the static electric field, right? Because the plus positive ions are repelling each other. But you against it, you are storing the positive ions in a battery. That is what is charging is, right? So when you charge it and you apply the wire, what happens? The stored, these positive ions will repel and will work, like do the work back, right? The energy stored will go back. So it's again potential energy, right? So it is also one of the potential energies, electric potential energy, right? We discuss it as voltage and the electromotive force. So those are energies as well. So voltage is one of the energies, you know, one of the potential energies. Get it? Right. So those are the type of potential energies, and basically what we discuss here is the gravitational potential energy, and the other one is elastic potential energy, right? So what is gravitational potential energy? This is the energy stored by an object when it's in a gravitational field. It depends on the acceleration of the gravity. Now when the acceleration of the gravity changes, the potential energy also changes. You have to consider it when it comes to the question. In some cases the acceleration is given less. Yeah, in some cases, let's say you are in space, so somewhere in another planet or something. So they give the acceleration as 4, 6 or 7 or something else. But with the practice, what you do is when you put E equals mgh, now the equation is E equals mgh. When you are putting the E equals mgh, because of the practice, you are putting the value 10 for the g. But the acceleration is given something else. You get it wrong, right? So when the acceleration changes, the potential energy also changes, right? Right. The vertical displacement of the object from the zero potential level and the mass of the object. Now it depends on the acceleration of the gravity, that is one, the vertical displacement of the object, the h, and the zero potential energy level. that is something we consider. There is no actual zero potential energy level, nowhere. That is something that we consider. Think something like this. So I'm taking this mass from this level. Let's say I'm going to lift it from this level to this much of a height. Let's say which is half of a meter, right? So this is, let's say, 1 kilogram. I took it up to half of a meter, and the energy gets stored here is E equals mg h. Can you calculate it and tell me? M is 1 kilogram, G is 10, H is 0.5. So altogether, what do you get? 5. So that's a 5 joule. So if I lift it here, lift the bottle from here to here, it will store 5 joule in the bottle. Get it? So is it the actual energy got stored there? No, right? Is it the actual energy stored there? No. It's a relative energy. Relatively to this height, it's only 5 joules. But if you take the whole length from down here, it's more than that, right? It's more than that. Yeah. So relatively, it's a relative one. So if you take the zero gravity level here or the zero potential level here, like up from that will give you a plus value, right? If you take it from here, up from that will give you a different plus value, right? So there's no actual zero potential level, right? Now if I take this building has a height, right? So from that height it has a different potential energy. But though if I go to the ground floor, still there's a place lower than that ground floor level, isn't it? Because this is one of the islands. So there we have mountains. Now let's say we are in a mountain and there should be another place which is lower than that one. So if I compare to that level, now this ground level is not 0, isn't it? So there's no actual zero potential level. That is what we consider as 0, and the values above it is a plus value. Right? අපි level එකක් consider කරනවා. Values above it is a plus value, and the values below it is a minus value. Simple as that. That's all. Right? අපි 0 level එකක් consider කරනවා. එතනින් උඩේව තමයි plus, එතනින් පල්ලෙහාව minus. එහෙම actual එකක් නැහැ. එහෙම බෑනේ. මොකද ground එකට එහෙම 0 level එකක් නැහැ. You can't find any 0 level in the ground. Get it? Right. So it is what it says here. In solving problems, any point can be taken as 0 potential level. The potential measured above it can be taken as positive, and the potential measured below can be taken as negative. Right? So the equation is what? E equals mg h. So there will be questions of it. Now come to the elastic potential energy. Before it, shall we do this question? Do the first 2 questions really fast. Can you? Now take this value as 10 meter. Cancel this one m because it's not millimeter, it's meter. 1 meter. Oh, if it isn't given, take it as 10. $530? Be more than 5:30, right? We usually start at 3 or 3:30. And then 5:30. Oh. Yeah. Doesn't matter. ඔයාට මේ ස්ලාන්ට් එක දිගේ අරන් යන්නත් පුළුවන්. මෙතනින් උස්සන්නත් පුළුවන්. Think of it. Done. Right? Got the answers? අපි කලින් ක්වෙස්චන් දෙක ඩිස්කස් කරේ නැහැ. ඒ දෙකත් එක්කම ඩිස්කස් කරමු එකපාර. Then we'll come to the elastic potential energy. Spring constant එක ගන්න ඕන. ඒක පොඩි different theory එකක් තියෙනවා අපි ඒක ඩිස්කස් කරමු. Spring constant එක දෙන්න ඕන. ඒකේ හැබැයි අපි spring constant එක නැතු half f එකකින් ගන්න පුළුවන්. Force into extension half එකකින් ගන්න පුළුවන්. That is the proper equation and ඒකෙන් derive වෙච්ච එකක් තමයි spring constant එක දාලා ගන්නේ. half k e square. Done? Yes. Shall we go to the first question, like in the exercise 1? Come back. These first two. Right. So the first one is easy. What is the first one? First one says the amount of work required to move a mass 2 meters against a frictional force. Now listen, this one, 2 meters against a frictional force. So here the work is done against the friction, so we take it or we consider is work done by the friction. So the work equals Fd. So for the F we take friction and for the D we take the displacement. So it's more like the work done by the friction, but the actual thing is the work is done against the friction, right? Because here the F and displacement or the force and displacement are acting opposite, but the theory says force and displacement should be the same direction. We discuss it, right? So here the work is done against the friction. So simply what we have to put is W equals Fd. So now what is F here? 10 newtons, right? So F is 10 newtons and the displacement is 2 meters. Together it gives a 20 joule, which is answer 5, right? And this one, question number 2. Now the actual work is done by 100 or its component. Actual work is done by its component, which is 100 cos 30. So the formula should be W equals Fd cos theta, which is cos 30. So F is 100 and the displacement is 170 centimeters. You have to convert it into meters. So 170 divided by 100, which is the meters now, and the cos 30 is root 3 over 2. So simplify this. 100 to 100 cancels out. 170 divided by 2 is how much? 85. So the answer is 85 root 3. Get it? So the answer is 4. Good. Now come to the other two questions. Right. So the first question, when a metal block of mass 900 gram is placed 10 meters above the ground, the potential energy stored is. So now the equation is EP equals mgh. EP equals mgh, right? So mass is 900 grams, you have to convert it into kilograms. So you have to divide 900 by 1000, and g is 10 gravitational acceleration, and the h is 10 meters. So this 0 to this 0 to 2 zeros will cancel out, and 1 0 to 1 0 will cancel out. 90 joules is left, isn't it? Second answer, right? Second answer, 90 joules. So this question, there is mass of 40 kilograms at the bottom of an inclined plane as shown in the figure. The work required to move this mass along the inclined plane, which is this one, right? AB. Along the inclined plane to B is, assume that AB is a smooth surface which is like no friction applied, right? So how do you find it? No idea. Think of something. How do you find it? It can like, so the object is moving in the slant, over the slant, right? So if we so if we are to consider the force and the displacement in the direction of the slant, it will be different, because now the weight is given how much? 40 kilograms, which is acting downwards. We don't know the force which is acting in the direction of the slant, do we? We don't know. එතකොට මේ force එකේ component එකක් ගන්න වෙනවා. Can we take a component? Component එකක් ගන්න පුළුවන්ද? This is a good question. Now tell me. හරිද? මෙන්න මෙහෙමනේ තියෙන්නේ. So the mass is right here. කියලා හිතමු. So it will be how much? 40 kilograms is 400 newtons. And the angle here is 30. Length here we don't know, but we can take it. Say it's L. And the length here is 10 root 3. There's two ways doing this, right? Put the brain. So you don't know the force acting in this direction. Can you take it or not? Can you take the force in this direction? පුළුවන්. එතකොට 400 එකේ මොකක්ද දෙන්නේ? Component. So how do you take the component of 400 to this direction? Take a different color. මෙන්න මේ component එක ගත්තා නම් හරි නේද? නේ? The work is done against it. Right? So how do you find this component? You have to have an angle. Do you have the angle? මෙතන 30 degrees නම් පුළුවන්. එතකොට මෙන්න මේ දෙන්න නේද? මේ දෙන්න නේද? yes. මෙන්න මේක ගැන නේද කියන්නේ? එතන මෙතන 60 එහෙනම් මෙයාත් 60. so එතන මෙයා කීයද 400 cos 60. දැන් මෙයාව දන්නවද L එක? ඒකට දාන්න no not tan. ඔව් cos දාන්න ඕන. මොකක්ද? මෙති? cos එක මොකද්ද? yes. no. no yeah adjacent over hypotenuse right. so මේකට cos දැම්ම නම් L හොයා ගන්න පුළුවන්. if you put cos 30 to this one, considering this is a triangle, cos 30 equals hypotenuse over no adjacent over hypotenuse, so 10 root 3 over L, and the cos 30 is how much? root 3 over 2 equals 10 root 3 over L, so root 3 to root 3 will cancel out, so L will be equal to how much? 20. now we have the component here 400 cos 60, length here 20. now you have to take the what? the work done. W equals FD. so what is the force here? 200 cos 60 and the D is 20, isn't it? so 200 cos 60 is how much? cos 60 is half, right? sorry, not 200, 400 cos 60 ne 400 niti 400 cos 60. cos 60 is half, so it's 200 into 20 kiyada 4000, right? that's 4000 joules. that is one way of taking it. now that's if you use your brain. did you think of it? now that's the thing, you have to think it by yourself. you have to do it by heart. that's when you learn. otherwise you are trying to follow something that someone did, isn't it? මම මොකක් හරි කරපයක් follow කරන්න බලන් ඉන්නවා, that's not what is learning, right? you have to struggle it. මේක හිතන්න. when you are thinking won't this will come, this will definitely appear because you have the knowledge to solve it that way. you have it but you don't use it, right? you are not using the brain, that's the issue. do you get it? මේක එනවා පොඩ්ඩක් කල්පනා කරා නම් struggle කරා නම් this way will come, right? maybe it's me much of a ටිකක් දිග වේ එකක්. this is much of a දිග වේ එකක්. you don't have to do it this way. instead because මෙයා මෙතන ඉඳන් මෙතනට යනවා කියන එකේ ඇත්තටම වෙන්නේ මේ weight එක vertically යනවා මෙන්න මේ height එක. එතකොට vertically මේ height එක යනකොට force එක තියෙන්නේ කොහෙටද? පල්ලෙහාට. එහෙනම් A force එකයි මේ තියෙන displacement එකයි consider කරත් ඔයාට එන එකම work එක. මේකෙදි අපි කරේ මොකද්ද? object එක මේ පැත්තට move වෙනවා කියලා consider කරපු හින්දා A direction එකේ තියෙන force එකයි displacement එක ගත්තේ. object එක මේ පැත්තට move වෙනවා කියන එක consider කරා නම් A පැත්තට තියෙන height එකයි weight එකයි consider කරා නම් ඇති. නේ? get it? It's the same thing. Yeah? so එහෙම consider කරා නම් අපිට මෙන්න මේ height එක ඕන වෙනවා. නේද? අපි එහෙම consider කරා නම් මේ height එක ඕන වෙනවා. weight එක 400 ම තමයි. ඒතර මෙයාව ගන්න පුළුවන් කොහොමද? මෙයාව ගන්න පුළුවන් tan 30 දාලා. so tan 30 equals opposite over adjacent. so opposite over adjacent is 10 root 3, right? and tan 30 is 1 over root 3 equals opposite over 10 root 3. so root 3 to root 3 cancels out, so opposite equals 10. now this height is 10, and and the weight in that direction is, or the force in that direction is 400. So 400 into 10 is also the work, that is 4000, which is equal to this. Will give the same answer. So it has different ways. All the questions have different ways. The only difference is you don't think about it, huh? Think about it. Work and energy equal කරලා mgh. So this is what we did now. Oh, oh, oh. ඒක තමයි දැන් මේ කරේ. mgh එක තමයි මේ දැන්. Same thing. mgh දැම්ම නම් හරි. Same thing. There are different ways of thinking. Nee? Have to use the brain power. Have to think. Nee? Have to think. Otherwise nothing happens. So when you have a paper, now don't take the photos. Then like take a photo, that's all. You look good. Well, now listen, right? So now this is the thing, right? You have to think. When you have a question, don't struggle to move away fast. Okay, takes money. Right? So when you have the question, don't try to like ටක් ගාලා දුවන්න බලන්න එපා. Don't try to take the instant answers. නේ හැම එකම instant කරගන්න එපා, right? හැම එකම instant කරගත්තොත් මොකද වෙන්නේ? Nothing happens properly. The proper way takes time. Always the proper way takes time. You have the time, don't worry. Though it's a time එකක් තියෙනවා, හරිද? නැත්තේ නෑ, you have time, right? So do it the proper way, like struggle with the question. ටක් ගාලා answer එක ගන්න උත්සාහ කරන්න එපා. Have some struggle, have some thinking. That is how you improve your brain. Otherwise, O-levels වලින් මේකට ආවන් පස්සේ nothing has improved. When you go to university or other anywhere higher studies, nothing has improved. Nee? Is there a point? No. So this is improvement. Try it, think it differently. You may have different ways and have the same answer, like this one, right? Hari. Use the brain power, right? So at least what I'm telling you is දැන් මේ අපි කරන් යන ඒවා ටිකේ ඒ විදියට හිතන්න, right? So guys, it's almost 5:30 and the Zoom is finishing, and we'll do the elastic potential energy and the rest of the next week, and then by the next week the work power energy will be finished, right? So afterwards we are starting by the third week. What? By the third week we are starting circular motion. Yes, circular, the angular motion. And I was wanting to have a paper for the force. Right? We'll do a paper for the force. So you study, support each other. Not next week. We'll complete the lesson first, and like the end of the month, we'll have a paper. Right? I'll tell you. Right. So and the next month we are moving. Not we are, like myself. I'm moving to Shasip. And yes, no ISM anymore. It's still recording. It's recording. That's fine. So now the thing is, I don't have much of a base of students there in that place we stayed, and I have to move with the people who are already now there to the Shasip. And if you know any fellows that who we are moving to Shakti. Yeah, we are moving to Shakti and I am moving to Shasip. That's a different case. 2025 එක Shakti යනවා, 26 and 27 එක Shasip යනවා. So දන්න 2026, 27 ළමයින්ට කියන්න මේ සසිප් වෙන්න සර් කෙනෙක් ඉන්නවා. එයා වැඩේ කරලා දෙයි ගොඩ දාලා දෙයි කියලා මේ කියලා දන්න කස්ටිය එවන්න because මේ have to put some struggle. කියන්න දන්න අයට කියන්න and I'm planning to do some videos of awareness about the English medium technology. Are we needing your support? අපි පොඩි video clips ටිකක් ගහමු. Right? Even yourself I will be needing a video, not today. Can you know? Is it? I will do it next week. Doesn't matter, we have time. Next week with Yuhasa. Okay. Right. So guys, then we'll see you on next week. These people are staying for the next session. Is there a laptop or something?
No.
Understood? ඔක හදාගමු ටික ටික. questions ටික කරනකොට තමයි හදාගන්නේ. කාලෙන් මත් පොඩි. recording